These are simplifying radicals examples from Delta Math. So the instructions will say express in simplest radical form. So typically you could type these into a calculator. Unfortunately, most of them are going to turn out to be decimals, which is not radical form. You can, however, use those decimals to help confirm your answer. You can type in the original problem and the answer that you get as your final answer, and those two decimals that you get should match if you've done everything correctly. Now, this first one is actually a perfect square. 64 is 8 times 8, so the square root of 64 is just 8, and I hope that you get a ton of those. If you're not sure if something is a perfect square or not, you can type it into a calculator. If it comes out to be a whole number, you're finished. If it comes out to be a decimal, then we're going to have to treat it more like one of these ones. So what I'm going to do with 40 is I'm going to make a factor tree. You can split it into any factors of 40 that you prefer, as long as they're a pair, and you want to make it so that the numbers in your tree are prime, that you can't go any farther. So you don't need ones, but typically things like 2, 3, 5, 7, 11s are okay to have in your tree. Okay, so I'm going to start by just dividing by 2. It's one good strategy, although there are other things that divide into 40 like 4 and 10, 8 and 5. You can use those numbers and you'll end up with the same numbers at the end of your tree. But if you're not sure where to start dividing by 2. If 2 doesn't work, divide by 3, then divide by 5, then divide by 7, and so on and so forth. Okay, this one will also divide by 2. That'll be 2 and 10. 10 will be 2 and 5. All right, what I want to look for are pairs of the same number. So it looks like I have a pair of 2s here. And I also have this other 2 and this other 5 at the end of my tree. So this 2 means that we're going to end up with a single 2 on the outside, coming from the pairs. Now, if things don't have pairs, those get stuck underneath of the radical symbol. So I'm going to still have a 2 on the inside from right here. And I'm also going to still have a 5 here. Now, if you do have more than one number left either on the outside or on the inside, you should multiply those things together. So my final answer will look like 2 square roots of 10. Now, again, you can check this on a calculator by typing in this. It'll give you a decimal, and then typing in this number, it should give you the matching decimal. They should be the same. Now, the dividing by 2 trick is a little tedious and can be a little long if you have bigger numbers, but that's okay. If you're less familiar with them, the bigger numbers like 192, I'm not really sure what goes into that. So I'm going to start by dividing by 2 on each of these. Okay, now if I'm looking at this pair, 75 doesn't divide by 2, but it does divide by 3. 25 doesn't divide by 2 or 3, but I do know that it does divide by 5. Okay, I have a pair of 5s. That 5 is going to end up on the outside. And the unpaired 2 and 3 are going to end up on the inside. I do need to multiply the 2 and the 3 back together. Those will give me 6. Now, if the tree seems like too much work, there are other ways to think about this. You can think of 150 as 25 times 6. So you can break this down strategically into something that is a perfect square and something that's not. If you're really familiar with your perfect squares, this is a shorter strategy. If you're less familiar with your perfect squares, I recommend the tree. So what I can do is I can try to square root each piece. The square root of 25 is 5. The square root of 6 doesn't work. It turns out to be some sort of decimal, so I'm not allowed to do that part. So I still get to the same answer. It's just a different method or way of thinking about it. I'm going to stick with the tree for now. I think it's easier to see where it comes from. Okay, so I am going to bring my calculator in for this one because I'm not really sure what this is going to turn out to be. So I'm going to have 192 divided by 2. All right, looks like that turns out to be 2 and 96. 96 is still pretty big, but again, I'm just going to take it and try dividing by 2. Okay, I got 2 and 48. All right, if I divide 48 by 2, I get 24. And we're into numbers that are a little bit easier to recognize now. I can divide by 2 there, get 12, 2 again, I get 6. Lots of 2's on this one, 2 and 3. All right, again, we're looking for pairs of numbers. So I have a pair of 2's, another pair of 2's, and even a third pair of 2's. Wow. All right, so each of the pairs represents a 2 that's going to end up on the outside of our radical. So I'm going to have a 2 from the first pair, a 2 from the second pair, and a 2 from the third pair on the outside, and this lone 3 here on the inside. Okay, so again, the number of groups represents the number of those items that should be on the outside. So I have one group of 2, another group of 2, and the third group of 2 tells me that I'm going to have 3 2's on the outside. So if I multiply all those 2's together, I get 2 times 2, which is 4, times another 2, which will make 8. Okay, if you were doing this the shorthand way, you could take 192 and break it into 64 times 3. The square root of 64 is 8, and 3, it would give you a decimal. Either way, those final answers match, and you can confirm either way using a calculator to find a decimal answer for this and a decimal answer for that.